So the first bit, a guy throwing something in a river, it's a projectile. Sketch a path taken by the stone between leaving the child's hand and hitting the water. Projectile motion, so it's going along that way, but it's also accelerating down the way. So it starts off going down the way, getting steeper and steeper and steeper and steeper and steeper into the water. Importantly, there shouldn't be any sign of the stone going up, because gravity is always pulling it down, and he throws it horizontally, so it never goes up and then down into the river. The vertical velocity of the stone as it reaches the water, effective air resistance can be ignored. Okay, well, what do we know? We know that the acceleration is 9.8 meters per second. We know the initial speed. Well, do we? Vertically, what's the initial speed? Well, he's not throwing it down the way, so vertically up and down, the initial speed is 0. Calculate the vertical velocity as it reaches the water, so that's our final speed is what we're calculating, and the time it takes is 0.8 seconds. Put all this together, what formula do we know that relates to all that? Is this, A equals V minus U over T. Put in all our numbers, so 9.8 equals V, which we don't know, take away the initial 0, over time, which is 0.8. Well, V take away 0, that's just V, so let's write that. So 9.8 equals V over 0.8. I want to get this V on its own, that's being divided by 0.8, so let's do the opposite. V is 9.8 multiplied by 0.8. So our speed, when we do that, is 9.8 times 0.8 equals 7.84. We only get two significant figures here, so really we should just give our answer as 7.8 meters per second. Determine the height above the water at which the stone was released.